This is LeetCode code question number 1140. Stone Games, the third. This is medium question. Let's get into it. Alex and Rick continue their games with files of stone. There are a number of files arranged in a row, and each file has a positive integer number of stones. File size. The objective of the game is to end with the most stones. Alex and Rick take the turn with Alex start first. Initially, M is 1. One each player turn, that player can take all the stone in the first X, remaining 5, where X is greater than 1 to N and to M. And then after, if X selected 1 and X is 1, M is 1, so next is the M. But X selected 2 at this time, X is 2, next M is 2. That means that there are the piles of stone. So first player take 1 and the second player have the 2 choice. Take 1 or 2. If the second player take 2, third player able to take 4. Does it make sense? So the game continue until all stones have been taken. Assume Alex and Rick play optimally. Return the maximum numbers of stones Alex can get. This is the general minimax question to use deep learning. So we will solve it. Okay. Okay. Let me check with this one. I'm gonna solve with the recursion base. So I will check the combination to the best result, and then second I will accumulate sum to make the better time complexity. Okay, so my logic is first I will make SEC, and then I will, okay. Before that, let me explain this one. Okay, the first player able to get only 1 stone, and then if the next player get the 2 stone, and then the next player able to get 4, right? But the last, okay, let's check with the last, last third turn. Then third turn is I can get 4, but it remain only 2. That means I will get all of them, right? So at this time I can get 8. And then at this time another get 16. And then I can get 2. So finally I can get 10. And then there is another case is the second player take only 1, and then I can take the 2. So 1. So I will use the recursion to calculate every possibility, and then I will use the accumulate sum, because if I get this one, I needed to calculate 4 and 4 less of 1. But if I make the accumulate sum, no need to calculate more. So I make the 4, and next is 8 is 4 plus 4, and then 9 plus 8 is 17, and 17 plus 7 is 24, and 24 plus 2 is 26. So I will make accumulate sum like this. Then if I stay here, and then if I able to choose the 5, then I just return 17, because 17 is 9 plus 4 plus 4, right? Okay, awesome. So first I gonna make the accumulate sum like this, and then second I will gonna use the recursion to get maximum number. And then I would like to tell explain one more thing. Okay, that is the basis of minimax algorithm. Okay, if I when I get the maximum, that means quotient. Okay, I is the maximum. Mean is ACC I. This is quantity I can get maximum if the opponent did not get, but unfortunately opponent also get value. At this time opponent minimum something is my maximum number, right? So I will use this one as recursion relationship. Okay, let's start the code. First I will make the ACC, and then first I will put the last file. P-1 is this one, right? Because this one start is the same. And then I calculated the second. So for I in range length P-2 until 0, and then reduce one by one, and ACC I will append PI plus ACC minus 1. And after that I will ACC reverse. That means first I put 4 here, and then next I put 4 plus I is the 4, so this is second, 8, so add 8, and then next 8 with 9, 17, 24, 26, and then I will reverse it. 26, 24, 17, 8, 4. And then this one is same as this one. Oh, sorry, I'm missing one, 24, right? So now I rebate this one, and then I make the recursion names helper. Then I put 2 things. First this index, and then second is m. M is the start point, and then m start is 1, right? So index start with 0, so I will put 0 and 1. And then okay, let's make recursion have indexes I and m, and then recursion consists of 2 modules, base condition and recursion relationship. And then base condition is that if okay, now I is here, and then m is the more than 3, is 3 is the I return which number? Okay, 17, right? Because 3, 4, 5 I will take all, because this is last sum, so I will take the maximum, right? That is base case. So if I plus to multiply m bigger than length p, I will return ACC I. And then otherwise I return ACC I is currently I can get maximum, and then I need to deduct minimum of opponent. So minimum is mean, and then I start recursion help I and m, and I also put the x, and the x is for x in range is x range is 1 to 2m. So 1 to 2 multiply m. That's all? No, we need to add the 1. Plus, if we do 2m, and then x get 2m minus 1, because this number did not include. So the plus 1 means I would like to finish include x to 2m. So I will add x, and then next second thing is next m is the maximum m over x. So max m over x. Okay, let's check the code. Okay, it looks good. Okay, let's submit. It's too long. Do you know the reason why it happened? Yeah, that's right. We got the TLE, the region. Okay, let's check. The region is this one. So we check every combination, but sum is the must be the duplicated calculation, right? So we needed to get rid of duplication. What kind of the technique we needed to use? Yes, that's right, the memoization. So okay, let's adjust the memoization. I will use memorize the map, and then if INM is key in memo, I just return memo INM, and then after it did not in memo, I will calculate this one and then into the map memo. Okay, this one is the first I will make the map. That this one use the memoization. So after helper is running and the IM is in memo, just to use the stored one in the memory, the calculated. But if not, we need to calculate it. This one, right? So in this case, I will calculate it. I will skip this one because this one is constant, quite fast. I think the no need to put into the memoization memory to reduce the memory. And then second is the memorization IM, and then I calculate this one and then put into this one and then return this one. So next time, if the same IM is the put as argument, it just return is memoization map. Does this make sense? Okay, let's check. Awesome. Okay, let's submit. Okay, great. Okay, let's check the complexity. Okay, time complexity is let me check with the question. Okay, let's say if the first one the selected the two, worst case 2, and then second player able to select it, range is increased the exponential, right? 2, 4, 8, 16, right? So I can say, and then each the possibility we needed to recursion every time using this one. Even we use the memoization, this one is quite big. And then worst case, we able to use the memoization is frequency is quite low. So I think time complexity is worst case exponential 2 to the n, and space complexity is the linear space because we use the memoization. Thank you.